Hi all, today we'll be discussing the LeetCode problem of the day, Trionic Array 1. So you're given an array of length n. So an array is trionic if there exist indices p and q such that your array from index 0 to index p is strictly increasing. So this is index 0 until index p, all the numbers will be in strictly increasing order. And then from p to q, the values will be in strictly decreasing order. And after q, from q to the end of the array, which is n minus 1, the array should be strictly increasing. So if you have any such indices p and q in the array, then the array is called trionic. And you just have to return true if the numbers are in trionic. Otherwise, you have to return false. So if we check the first example, we have 1, then 3, 5, 4, 2, and 6. So if we see that the array is something like this. So this is P, it is increasing from index 0 to index P, and then from P to Q, it is decreasing, and then from Q to end of the array, it is increasing. And also you need to note that P is strictly greater than 0, and Q is strictly less than n minus 1. So P can't be at index 0, likewise Q can't be at index 0. They should be in between the array. So in the first example, this is a trionic array. So you return true. Now for the second example, first the number is 2, then you have 1, and you have 3. So here we can see that first it's decreasing and then it's increasing. So this is not a trionic array. So the output is false for the second case. Now coming to the constraints, n is from 3 to 100 and the numbers in the array can be from -1000 to +1000. Now let's go the approach. So I'll also be coding along with discussing the approach, since this is just a implementation problem. So you're given nums, and for it to be a trionic, it should increase till some point, then it should decrease, and then increase. So this is index 0, this is n minus 1, and you have p, and this is q. So you can just do a simulation. So starting from index 0, keep iterating on their indices until the array keeps increasing. So at some point, the array will decrease. So that will be your first value of p. So when you get the value of p, you just need to check that if p is lying in this range, 0 to n minus 1. Because suppose if the array is strictly increasing, then p will come out to be here, the last index of the array. So in this case, p is not valid. So you'll just return false for this case. So once you got the p, so p is satisfied, then we can run another loop, which will keep moving forward as long as the numbers are in decreasing order. So at some point, the decreasing nature breaks and the number increases. So that will be your index q. So again, the same thing. For q, you need to check whether it's lying in this range. So obviously q will be greater than 0. You just need to check that q is less than n minus 1. Because if the array is something like this, so here you found a p, but then your array is completely decreasing till the end of the array, and this is your q. So this is not a valid case because q should be less than the n minus 1. So it can't be equal to n minus 1. So if q is equal to n minus 1, we'll simply return false. So once we found p as well as we found q, after that, the rest of the array should be in strictly increasing order. So again, we can run another loop, which will increase as long as the elements are in strictly increasing order. So if at any point it will decrease, then you'll return false. And if not, otherwise, if it's strictly increasing, then at the end, you'll just return true. So let's quickly write the code for this. So first, let me take two variables, p and q. Initially, I'm just assigning them a garbage value. Also, n will be array length. So first, we need to iterate on the increasing slope. So I'm just taking a variable I, and initially it will be at 1. So as long as nums of I is greater than nums of I minus 1, it will keep increasing forward. Also, you need to check that I is also in the bound. So I is less than array.length, and nums of I is greater than nums of I minus 1, you keep increasing I. So in this example, for all these numbers, your while loop will continue. Once your I reaches here, when your I is here, nums of I is greater than nums of I minus 1, this condition fails. So the while loop breaks. So once you come out of the while loop, the value of P will be exactly equal to the previous index of I. So you can write P equal to I minus 1. So now once we found the P, we need to check whether P is lying in this range. So we can say that if P equal to 0, or if P equal to n minus 1, we can simply return false. So once P is found, we can repeat the same thing to find Q. But for Q, since it's strictly decreasing, we just need to flip the sign. And once this while loop is broken, so if we check this example, so as long as nums of I is less than nums of I minus 1. So this is nums of I, this is less than nums of I minus 1, the I keeps moving forward. So I will come here, and when I reaches at this point, nums of I less than nums of I minus 1 condition is false, so while loop breaks. And when while loop is breaking, I is here, so your Q will be I minus 1. So similarly, we can write Q equal to I minus 1 and also check the condition. So since P is not equal to 0, Q can be never 0 because Q is greater than P. So we don't need to check the case for 0. So we just need to check the case for n minus 1. So if Q equal to n minus 1, we can simply return false. So once we have found P and Q, we just need to check the rest of the array is now in strictly increasing order. So for that, we can use this. So this is the condition for strictly increasing order. So let me actually inside. Yeah. So this while loop is iterating on the rest of the array, and inside that, if at any point nums of I is less than equal to nums of I minus 1. So nums of I, the current number is greater than previous number, denotes the strictly increasing case. So if I just put a negation of it, so if it is false, then you can again say simply return false. And once this while loop is done, that means it guarantees that the rest of the array from Q to n minus 1 is strictly increasing. So at the end, we can finally return true. I think I need to add a bracket here. Okay, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So coming to the time complexity, since we are just iterating on the numbers array once, even though we are writing 3 loops, so overall, your I will run from 0 to n minus 1. So time complexity will be order of n. And coming to the space complexity, we are not initializing any arrays, just few variables p, q, and the I. So space is constant, so it will be order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.